Hello, David Snowpeck here from Snowpeck Games, and this is my fourth devlog about the game I'm making for the Godot Wild Jam number 24. So, unfortunately, I didn't get that much done last night. I was so tired. I've been staying up crazy late working on this game jam, and I finally hit my max, was only able to do a little bit of work, and had to go to sleep. But I'm going to show you the little bit that I did get done, and then I'm going to spend some time just talking about the different tech things and how some stuff was done in Godot, in case that's useful or interesting to other people making games in Godot. So, first up, let me show you what I did. I added a little bit of intro text here when you first start the game, explaining the controls real quick. And then I put in a whole bunch of triggers in the house to kind of bring the environment alive, give some things to interact with. So, we can go over and have the cuckoo clock go cuckoo. The piano will play Hot Cross Buns with a very little kid version interpretation of the words of that song. And some other, random little stuff. Again, just to try and bring the environment alive. I haven't actually started implementing any of the story parts that I had planned yet. But choices work. So if I go talk to Sasha, she will say, do you want to play, yes or no? And I did add in the little arrow using the suggestions that I got from people in the Godot Wild Jam Discord. Works with the mouse and the keyboard and the gamepad. And the choices matter. So I can choose yes, and she says, awesome. Or I can choose no, and she says, oh, I really want to play. So I've got all this stuff in there to make a narrative, dialogue choice-based story, but I just need to put the story in. And I will hopefully get that done tonight, because there's only a couple days left. I'm really worried that this is going to end up being just sort of like a boring tech demo of I kind of made a little system that could make a game, but this isn't actually a game. We'll see what happens. But to dig into the tech a little bit, I want to talk, I think mostly about the maps and how that works. So like I showed in previous videos, the maps are actually made in Tiled, which is an external tile map editor thing. It's really cool. It's been around forever. And they're imported into Godot via VNen, George Mark's tiled importer add-on, which works really great. It works very similar to how the importers for 3D models work. So if you have like a GLTF file, you'd put that in a directory under your Godot project. Godot would import it, and then you'd be able to treat it as a scene in Godot. And it's the same thing with Tiled. I put the TMX files, let me find them. They're under Maps. So the house, I see the TSCN. Here we go, house map TMX. I don't know why that's way up at the top. So this is a scene which it says we can't edit because it's an imported file. We can say open anyway. And let me show here. It imports each of the tiled layers as a different tile set node. And that's what it does. This is rearranged a little bit differently. Normally you wouldn't have this tile maps and objects and actors. Those are added by a post import script. So when you configure the import settings for a .tmx file, you can set a post import script, which I have set to this post import.gd file here, which does some modifications to the imported scene. Some of those probably aren't strictly necessary to be in a post-import file, but it's nice for me because it standardizes the layout of these scenes. I could, always just, when I make a child scene of that imported scene, I could rearrange the nodes myself, and that would work fine. But this way, that is standardized across all the other maps that are using this post import. So that's adding, this tile maps and objects node. It grabs all the tile maps and puts them in there. Anything else it finds, it puts under objects, and it also makes this actors node, which it doesn't put anything in, but has special meaning to the map.gd script file, which also gets set here. So we also set a script, a map script that gets attached to all of the maps here to kind of standardize the way that the behaviors that I want to have on each of the maps. And some normal stuff that you usually do in a post import. So there's some extra metadata that you can attach to layers or objects or tiles in tiled, and then in your post import.gd, you can have Godot do something with it. So by default, it just gets added to the metadata for a node. And in this case, I'm taking this z-index value and setting it to the Godot z-index property. And this is how we have, there's one layer, the overhead layer, which goes over the player. I can show you really quick in the game. These torches that are hanging up here are above the player, and that's because their z-index is higher, which comes from tiled, which I realize I should have shown you since we were talking about it. Rather than just waving my hands around, I can actually show you the custom properties. So here's the overhead layer in tiled, and then I have a custom property over here, z-index 1. And so you can set whatever special properties you want in tiled and have them mean something in Godot via the script. You can also use, like tiled has the ability to set up layers, or not layers, I'm sorry, objects, which I'm not using here, but is very useful. They by default get turned into areas or different types of physics bodies, depending on the type attribute that you set on them. I'm not using it here, but you can also set up the collision shapes for individual tiles in tiled, which then get imported to Godot into the Godot tile sets, which also can have collision shapes for each tile. So the tiled import plugin, super cool. So anyway, it restructures things, adds the z-index, sets a script, and then I also make a child scene. So we have the house map TMX, which then has an inherited child scene, the housemap.tscn, which then throws the NPC under actors, which gets treated special by the map code. Particularly, it makes the actors disable parts of the pathfinding and marks the tiles they're standing on as unwalkable. And it has to do that differently than it does for tiles because actors move around, right? And then here I add in like all the different triggers, which is, special trigger area scene. And then, we can wire that back to the main script. And when those areas are triggered, like the oven trigger, it will say, careful, the oven is hot. Or the one with the choices up here, it says, hey, Ava, do you want to play? Yes or no? And then we have this yield to wait for the action to be completed. And then we can grab what was the last choice. Was it yes or no? And show the different message. That's not super interesting. I think the more interesting part here is the default map code. So this game is all tile based. Like all of the motion is done on a single tile, all of the collision is done based on tiles, and that all comes from this map.gd. So the first thing that happens is the map.gd sorts out which of the tile maps are which. So another custom property on here. So we have the floor tiles. They don't have any custom properties on them, but the floor layers, I gotta get my terminology right, don't have any custom properties on them, but the wall layers have this custom collision property, which gets interpreted by the map.gd to say, okay, all of the tiles on one of these layers marked as collision will be non-walkable tiles, and all of the tiles that are not on a layer marked as collision will be walkable. So first it sorts out, okay, these are the collision tiles and these are the walkable tiles. It doesn't count anything that has a z-index that isn't 0, so it doesn't even worry about those overhead lanterns. Those don't get counted for anything. And then it sets up an A-star 2D with all of the points in the A-star being tiles that are walkable. And this is how it does all of the pathfinding. So it builds up, this network of walkable tiles from across all of the layers of the tile map into a single A-star, and then we're able to, click on that tile and plot a course and get there. So here's where it's setting up the A-star. It's just saying, is it walkable? Add the point, and then it goes back through a second time and connects all of the adjacent tiles. Yeah, and this plot path is used in the pathfinding like I was just talking about. We have a start position and end position. It figures out what those points are in the A-star graph, asks the A-star to, we do a little bit of stuff here for the actors like I was talking about. So first we go through and make all of the A-star points be enabled. And then we go through the list of the nodes under the actors parent here and mark all of the positions that those actors are standing on as disabled in the A-star. So when you're plotting where you're walking, it won't, try to walk through one of the NPCs. It'll just say, okay, I can't walk there. And then it gets the path and turns that into a series of movement vectors and returns it. And yeah, that's really all that's interesting there. As far as the movement, both the NPCs and the player descend from a single scene called actor, which maintains a tile position, which is like the real position of that actor as far as the game is concerned. We don't really care about screen position. It's all about tile position. So when we move a character, we immediately update its tile position to the new tile that we want to be on, which we've already pre-checked as being walkable. And then we use a tween to just animate the screen position to put them there. And of course, the animations are important to other things, like I was talking about in a previous episode that I wanted to have it so that when the player stepped onto a trigger area, the trigger got triggered after they finished moving there. So we do a lot of stuff where we're waiting for the animation to complete, but as far as the game state is concerned, we only care about tile position and not the screen position. Yeah, that might be all the interesting stuff there is to talk about. I mean, I guess the trigger areas are a little bit interesting. They're just areas, plain old areas. We don't really do much on them other than set up a special signal and have a special enum type, so we can say, is this a action area or a player touch area? The way they are activated is a little bit interesting. So like I said, we basically do a thing and then say, okay, does that trigger any trigger areas? So when a player finishes moving from one spot to another spot, we say, okay, check if we're overlapping any player touch trigger areas. And then if we are, activate them. Or if the player hits the action button, let me open up the player scene really quick. Okay, so the player scene has a raycast, and when the player presses the action button, we basically say, is this ray intersecting with any trigger areas that are marked action button? If yes, activate them. So very simple stuff. I think, yeah, technically this isn't a super complicated game, but what I really like about it, what I think has been a success about it, is just how solid it feels. There's all of these relatively simple things, but they all have to work together and manage their state right and do the right thing before the next thing. And there's a whole bunch of things with like inputs, like, okay, so this thing is going to be input, this thing's going to be GUI input, this thing's going to be unhandled input, and just getting all of that stuff lined up right to make it like really feel like a tight experience, that these tiles aren't just an imaginary number and we're animating a thing, but like your character is really on that tile and have everything kind of behave rationally. So I don't know. I hope that was interesting. If anyone has any questions about how any of this stuff works, let me know. I'd be happy to dig deeper into anything or clarify any part of the tech here if it's interesting to you. So thanks for watching. Talk to you later. Bye-bye.